Today we're going to continue talking about our functions with representations of functions. So as we've been talking about, the function rule, is an equation that describes the relationship between inputs and outputs. The input value is called the independent variable. Because it can be any value in the domain. The domain is another way of saying our x's. The variable that represents the output value is called the dependent variable. Because it depends on what the independent was. So again, independent, let's put a little note here, the independent is the x value, the dependent is the y value. The other thing that I think might help some of us, the word input has in to start it. The word independent has in to start it. So the input is what we put in. That is called the independent variable. That is your x value. The y value is the dependent variable. It needs to wait for you to plug in the x. So writing function rules. So to write a function rule, basically we're just writing an equation. So a function rule is really write the equation. So we've been writing equations. In this case, you want to be looking at the wording to see what you think it will become. So a function rule is really another way of saying write the equation. So here's the first one. The output, well, which is the output? Well, we said the output is the y value. The word is our equals sign. 5 less than the input. So you got to be careful on the less than. The less than is subtraction. Lots of times we see 5 minus, but in this case, what you have to think about is it's the input minus 5. 5 less than the input. So we have to think about that. So the input would be our x value. We said less than is minus, and then the number 5 for the word 5. So there's my function rule, or my equation. Y equals x minus 5. So example B. The output is the square of the input. So the output, again, would be our y value. Is my equals sign, the square of the input. So think about that. To square something is something times itself. Input is x. The square would mean that notation to say it's x squared. When we evaluate a function, so evaluating a function is really the same idea when we say plug it in. So evaluating a function is nothing new. We just have to understand what it means to evaluate a function. So y equals 2x plus 5 when x equals 3. Y equals 2. With the 3 is going to go in. Now I just follow regular order of operations. Y equals 11. So again, nothing new here. In the past, we would have said, find the value of the equation when x is. It's the same idea. We're just using the terminology of function versus equation. And then just as a kind of a summary of what we've been talking about, these functions as graphs and tables. So the function can be represented with an input-output table and by graphs. So this is the first time we've seen that in this chapter, but it made sense. We talked about it in 7.1. So an input-output table is comparing x's with y's to make these ordered pairs. That makes it a function, or at least a relation. But also, we're going to notice here, we're going to see things called functions as a graph. It's another bunch of ordered pairs. So When you think about relations, you can graph them. Functions, you can graph them. The one thing that you also want to notice is we have a nice straight line here for this to be the function. So here's something on example 3 that we've done in the past already, back in our graphing chapter 4. Making a table and graphing it. So we have the equation y equals negative 2x plus 1. We want the inputs of those numbers there. So I'm going to pause the video and I'd like you to fill this table out. Remembering the way this works is the inputs are going to go in this first column. You're going to run them through the equations to get the outputs to then create the ordered pairs, and then you can make your graph. So I'm hoping you have the same thing, and hopefully you can now see where this all comes from. So this was back in chapter 4 as well, when we were graphing the equation. Now we're just using the word function. So negative 1 was our input. I plug it in here where the x goes. Negative 1 times negative 2 is a positive 2, plus 1 is 3. So negative 1, 3 was my first point. 0 goes in. This becomes 0 plus 1 is 1, so 0, 1 is a point. This goes in as a 1. Negative 2 plus 1 is negative 1, so 1, negative 1 is a point. And lastly, negative 2 times the 2 that goes in is negative 4, plus 1 is negative 3. So then I would plot my 4 points, connect my line. You should be using a nice perfect straight edge to see a nice straight line, and that's how you would graph the function. And then lastly, just as a quick summary. So representations of functions. We've seen them now in a bunch of different ways. We talk about it in words. So you can take a sentence like this and you can write y equals 2 plus x. So you could turn it into an equation. So here is the y equals x plus 2. We could see the input-output table. You could see it in the mapping diagram. And then lastly, we've just talked about how you can see them in a graph. So again, we've done all of this work back in our equation and graphing equations chapters earlier this year. It's just another way of representing these. We're looking at new vocabulary with functions and relations. And if you have any kind of questions, please feel free to let me know the next time I see you in class.